Alright, y'all, so here's some help on Unit 3, Section 3's homework. I assigned 1 through 6. I'm going to go through, go ahead and show you how to do these, just in case you maybe missed a lesson or need a little bit of like a refresher. On these questions, we're writing the equation for these polynomial functions. So we're kind of going to be working backwards. Like we have the end behaviors because we can look at the graph. But the best place to start is really looking at the x-intercepts. All right, so if we start by looking at the x-intercepts, we have one right here at -3. We have an x-intercept at -1, and then we have an x-intercept at +1. Those are the three values that they give us. Now, because they give us those three values, I'm just going to start our equation out. Because they give us those three values there, we know what the factors look like, right? We can say what the factor looks like that gives us a -3 for its x-intercept, right? That has to be a factor of x plus 3, right? Because if you go x plus 3 equals 0, subtract 3, you get that -3. Now, similarly, for this x-intercept at -1 right here, we can say there's a factor of x plus 1, and for this last one, this x-intercept at +1, there's a factor of x minus 1. Now the only thing we have to add on there is if you look at these specific x-intercepts, right, are they bouncing off the x-axis or are they passing through? Now if you look at -1 and +1, both of them, they go from like the top quadrant to the bottom quadrant or the bottom quadrant to the top quadrant, meaning those are passing through, so they would need an odd exponent. Now the nice thing about passing through an odd exponents means we can just have these as a power of 1. We don't really have to add anything else on that. So we can just leave those as x plus 1 and x minus 1 to the first power. For this x-intercept at -3 though, notice how we get to that x-intercept and then we shoot right back up into that same top two quadrants. That right there is a bounce, and since it's bouncing, that means we're going to have an even exponent, so we're going to make that x plus 3 squared. Now we made that x-intercept bounce. With that, we can start writing our equation, right? We can say there's an x-intercept at x plus 3. It's squared because it bounces at -3. There's an x-intercept at -1 that gives us that factor of x plus 1. There's an x-intercept at +1 giving us a factor of x minus 1, where these two here, we're just going to keep them without exponents because that's what causes them to pass through. Now the last thing that you have to do on these writing equations problems is we have to figure out what is this leading a value here, because there usually is an a value that we can find. However, on this problem here, because they don't give us any other point on the graph other than x-intercepts, we don't have to plug in a point and find this specific a value. We can choose whatever we want. The main thing is we just need to make sure that that a value matches up with our end behaviors. Okay, so how we're going to do that is look at the right end behavior, right? If we look at this, if we found the degree, we have this a out in front, which is fine. You multiply these x's, that's an x squared times x, which is some a value x to the 4th. Even exponent, they go in the same direction. We need that a to be positive because it's going up, so we can choose any positive number we want there for our a value. So let's just say what, like +4. You don't even have to write the positive sign, just say 4 with our factors of x plus 3 squared, x plus 1, x minus 1, giving us an equation that represents this graph here. Again, because they don't give us some other point on the graph, we can't find the exact value of a, so we can choose any value we want as long as it makes our end behaviors work the way they should. But that finishes number 1. I'm going to go ahead and move on to the next one. Alright, so here's number 2. I'm going to go through it a little bit quicker. If you need any more explanations on some of the pieces, go back to number 1. I did a real in-depth explanation. But on number 2, just like we did on number 1, we're writing the equation. That's what we're doing on this entire section here. And the best place to start is right here at the x-intercepts, because that gives us a whole lot of information. Now notice how we have an x-intercept at -2, giving us a factor of x plus 3. We have an x-intercept over here at +3, giving us a factor of x minus 3. And this is an x-intercept, and it's there at 0, right? So there's two different ways you could think of that factor to give us an x-intercept of 0. One way is it's just an x, right? That gives us a factor of 0. Or if you need to, represent it as x plus 0. So those are the factors that give us those x-intercepts. The second thing that we look at for the x-intercepts is it passing through the x-axis or is it bouncing off of it? Right, so you look at it, at -2 we go from the top to the bottom passing through the x-axis, which means it's an odd exponent, so we can just leave it as a 1 there. Okay, now when it's an odd exponent, just leave it as a 1, you don't even have to write the 1. We get here to this factor of 0. Again, we're going from the bottom to the top through that x-intercept right there, meaning we're passing through, again, odd exponent. We're just going to leave it as a 1. And for this last one here, that x-intercept at 3, again, we're passing through. We're going from the top to the bottom through that point, meaning we're passing through one last time. Again, odd exponent. We're just going to leave it as x minus 3. With that, we can start writing our equation. Right? We can say y equals, we have our x-intercepts of x plus 2, x minus 3, and if you want to represent that last one as x plus 0, that's fine. We have 3 x-intercepts. All of them, we're not adding exponents because they're all passing through. Now again, the last thing here is when we're writing these polynomial equations, we have to find this leading a value because that's going to determine the end behaviors of our graph. So real quick, let's figure out what would our degree and leading coefficient look like if we just kept it as an a. So we're going to take that a, multiply it to this x times this last x, which is good because that's giving us a degree of 3, meaning they go in opposite end behaviors, which is perfect. And then we can determine should that a value be positive or negative, because that leading coefficient there tells us what happens on the right side. Since the right side is going down, that means our a is going to be negative, or our leading coefficient is going to be negative. So all we have to do is choose any negative number that we want here, plug it in for a, and that will finish off our problem. So let's just say, I don't know, -2/3. It's a negative number that makes the right side go down, and everything else will follow suit. -2/3, x plus 2, x minus 3, and x plus 0. That's how you can represent this answer. Another way, if you don't write that x plus 0, you can say -2/3. Let me go with that again. And instead of writing x plus 0, you can just say x plus 2, x minus 3. Those are the same answer there. So just keep that in mind. Other than that, that finishes off number 2 for you. All right, so here's number 3. We have one little extra step here, and it's because notice how they're giving us this extra point out here attached to our graph. Because they're doing that, instead of us just choosing whatever a value we want, we can actually find that specific a value, and that's what we're going to do here. But the steps are going to be the same. We're writing an equation, start with the x-intercepts. So we have 3 x-intercepts. We have one here at 0, one at +1, one at +2, and let's figure out what information that's telling us. Now this one at 0, it's an x-intercept of x plus 0. Again, if you want to represent it like that, or just write an x. This x-intercept at 1 gives us a factor of x minus 1. This x-intercept at 2 is a factor of x minus 2. Now before we start writing our equation here, let's look at those x-intercepts bouncing off the x-axis or passing through it. So for x plus 0 here, we go from the bottom through that x-intercept to the top. That's passing through odd exponent. We don't have to change anything there. For the 1, we're going from the top through that x-intercept to the bottom. Again, that's passing through. We don't have to change anything there. For the 2, we're going from the bottom two quadrants, passing through that point to the top. Again, that's passing through odd exponent, which means these all get a 1, but let's not even represent that 1 because we don't need to write an exponent of 1. With that, we can start writing our equation here. Right? We can say y equals x plus 0 to the first power, x minus 1 to the first power, x minus 2 to the first power. Again, none of those get exponents because they're all passing through. And the difference here is we need to find this a value, and instead of us just saying, oh, the right side goes up, this is going to be a positive, we can find that specific a value right there by taking this point that they gave us, this negative 112, and substituting it in. So we're going to take negative 12 and substitute it in. So I'm going to say plug in negative 1, negative 12 for x and y to find a. So what that looks like is everywhere you see an x, you're going to put negative 1. Everywhere you see a y, you're going to put negative 12. So it should look like this. Negative 12 equals, I'm going to keep that a in purple. Then we're going to go this, negative 1 plus 0, negative 1 minus 1, negative 1 minus 2. Right? Everywhere there is an x, we plugged in negative 1. Right? Negative 1. And then for the y, we plugged in negative 12 from that coordinate point. Again, we're doing this because they gave us a point that's not an x-intercept, so we can actually find the a value. And now it's just make sure you're being careful while you simplify. This is negative 12 equals this a value. Negative 1 plus 0 is negative 1. Negative 1 minus 1 is negative 2. Negative 1 minus 2 is negative 3. Get a calculator if you struggle with doing some of this math, because all we're going to do here is simplify by multiplying. Negative 1 times negative 2 is positive 2. Positive 2 times a negative 3 is negative 6. And the last thing that we do to get this a by itself is divide both sides by negative 6, giving us that a value equals 12 divided by 6 is 2, negative divided by negative, then negative divided by a negative is a positive. So we get positive 2 there for our a value. Now we're not done. It's not like, oh, a is 2, we're done. The question is, write the equation. So we're going to take that a value of 2, substitute it right back into the top, and that will give us our final equation, which I'll write here. So our equation is y equals, our a value is 2, that's what we just found. And then we can say x plus 0, x minus 1, x minus 2. So when they give us that point, that's not an x-intercept, right? Sometimes they give us a y-intercept, sometimes they just give us a random point. You have to find the exact a value because this is the only equation that will represent this specific graph. All right. Okay, so here we go with number 4. Again, we're writing equations for these functions, and where we're going to start is the x-intercepts. So we have this x-intercept here. It's at negative 1. That's a factor of x plus 1. We have an x-intercept here at positive 1. That's a factor of x minus 1. And we have this last factor here, or this x-intercept at 2, another factor of x minus 2. Let me move this x minus 1 so we can look at it. Okay, now this down here is not an x-intercept. Do not write a factor for it. That's a y-intercept. Okay, second thing we do is look at those x-intercepts, determine do we have to add an exponent, right? Bounce or pass, bounce off the x-axis, or is it passing through? So for this x-intercept here at negative 1, look at it. It starts the bottom two quadrants, we hit the x-axis, and then we bounce down. That's a bounce, meaning we need an even exponent, so we're just going to put a 2 there. Now it's a bounce. At the negative 1, we're going from the bottom two quadrants, we pass through the x-axis, and the top two quadrants, that's passing through. we're just going to keep it as exponent of 1. And then for that last x-intercept at positive 2, from the top 2 quadrants, we pass through the x-axis to the bottom 2 quadrants. Again, that's a pass-through, odd exponents. We don't have to add anything there. And with that, we can start writing our equation. Right? We can say y equals, we have this x plus 1 squared, because it's bouncing at negative 1, x minus 1, x minus 2. And the thing we have to remember here is we do need to find that a value. And this is where this y-intercept of negative 3 comes in. That y-intercept at negative 3 is a coordinate point 0, negative 3. Because they gave us that, we can find the exact equation to represent this graph here. And what we're going to do is we're going to plug in 0 for x, negative 3 for y into that equation, and we should be able to solve it. So we're going to go negative 3 equals I'm going to try to color coordinate this as best as I can. 0 plus 1, sorry, I'm just adding those. 0 plus 1 squared, 0 minus 1, and then 0 minus 2, right? Everywhere we see an x, we're plugging in 0, and everywhere we saw the y, we're plugging in negative 3, because we're plugging in this coordinate point, this point that they gave us that's not an x-intercept. After that, you just have to be careful and simplify. So we're going to go negative 3 equals 0 plus 1 is 1, 1 squared is 1. 0 minus 1 is negative 1, 0 minus 2 is negative 2. So negative 3 equals 1 times 1 is negative 1. Negative 1 times negative 2 is positive 2. We end up there. Negative 3 equals a times 2. You're dividing by 2 to finish off this problem, and we get that a equals negative 3 over 2, which makes sense because that right side is going down. We could finish off our equation by saying this a value, we're taking it, substituting it back in our final equation, and our answer is going to be y equals negative 3 over 2. That's the exact a value that we needed. X plus 1 squared, x minus 1, x minus 2. And that finishes off the equation that represents that exact polynomial function right there. Alright, so on 5 and 6 is a little bit different. It's just because we have to do some graphing along with writing the equation. But it's going to be a very similar process. First, what it's telling us here when it's saying cubic is it's telling us what the degree of our function is. Cubic, that means 3, so this function has degree of 3. That's going to help us kind of write our equation here. After that, it gives us some coordinate points, so let's graph them, right? Negative 7, 0. 5, 6. Negative 7, 0 is right here. Negative 4, 0. It's another x-intercept. And then 0, 7, that pops us up here. That's a y-intercept. 3, 0 gives us a third x-intercept. And from that, we can actually write our equation. Now we're going to go through the same steps, right? Let's start by looking at the x-intercepts. We have one at negative 7, and what we know is that gives us a factor of x plus 7. We have one at negative 4 here, and again, that's a factor of x plus 4. And we have this last x-intercept here at positive 3, giving us a factor of x minus 3. Okay, with that, we can start writing our equation, and we'll figure out what we have to do with the pass-through or bouncing right here in a second. So what we can say is y equals, we have our factors of x plus 7, x plus 4, x minus 3. Again, don't forget we have to find this a value. And what we know is because this has a degree of 3, right? That means that when we find that leading term, the highest exponent you see is 3, but look what happens here. This has a degree of 1, this has a degree of 1, this has a degree of 1. You add those together, that's a total degree of 3 already, so we can't do anything, we can't add any exponents. This function already has a degree of 3. Again, what we did there was essentially find the degree and leading coefficient when it was in its factored form. It already has a degree of 3, so we can't change anything. If we add an exponent of 2, now it has a degree of 4. So we're not going to change anything about those factors, which means they all have odd exponents, telling us that at every single one of these x-intercepts here, we're passing through the x-axis for when we graph it. Okay, now to finish this off, we actually need to find the a value, that leading value, because that's going to tell us what the end behaviors are. Now, because they gave us the y-intercept, they gave us a point that's not the x-intercept, we can find that specific a value by taking whatever that is, 0, 7, and substituting it in for x and y. Right? We're going to plug in 0 for x and 7 for y. 0 plus 7, 0 plus 4, 0 minus 3. This is going to give us the exact value. Do some arithmetic here. 7, 4, and negative 3. Multiply carefully. 7 times 4 is 28. And then negative 3 was 28 times negative 3 is 84. And then we divide both sides by negative 84. Which almost finishes our problem here, but we always want to check if we can reduce. Now the only thing we can try to reduce by is 7, so see if 84 can be divided by 7, and what I notice is you can divide a 7 out of both of these, reducing it down to a 1 over 12 negative, which allows us to actually finish off our equation here, right? It's a negative 1 over 12 for our a, so we're going to take that, substitute it right back in. That'll give us the equation to represent this graph. It's a negative 1/12. I'm going to write our factors. X plus 7, x plus 4, x minus 3. Okay, so that's the equation. Now what we have to do is actually finish off the graph here. And how we're going to do that is what we just found out was that our a is negative 1/12. So if we took that a and we put it back in here, that's a negative 1/12 there. It's a negative 1/12 there. And what that tells us is our leading coefficient is negative. So the right side has to go down. And we can actually do our graph now, because if we know that the right side goes down, we just have to follow our own directions. So the right side goes down, we get to that point, we're passing through that point into the upper two quadrants. So you pass through the point, go up to that y-intercept there, make sure you come back down to our x-intercept at negative 4. Again, we're passing through, so we're going from the top two quadrants to the bottom two, come back to that last x-intercept at negative 7. Again, we're passing through, going into those top two quadrants, finishing off our graph where we have opposite end behaviors because it's an odd degree, and the right side's going down because we had that negative leading coefficient. That finishes off number 5 for you.